So making decisions. How many of you like to make decisions?
Yes.
How many don't like to make decisions?
No.
They keep you up at night.
I sleep.
Every second of the day, you're inherently making a decision, right? Some of them are automatic decisions, like whether or not you're going to breathe, or whether or not you're going to remember what you see, whether or not you want to listen, whether or not you want to tuck something away in your memory. You're making decisions all the time. Whether or not you want to watch a video in class rather than listen to Mr. Rogers, right? You're making decisions all the time. And in computer programming, what we tend to call these are branching logic. So branching logic is simply what you would think of it like the branch in a river. You're going down in the canoe, and you reach a branch, and you have to make a decision. Do I go left or do I go right? And there's always a criteria that will determine whether you go left or you go right. Now, understanding what that criteria is very important. Maybe the branching logic, the criteria is that you'll always go right. If you come to a branch in the river, you always take the right branch. That is a piece of logic. It meets a set of criteria. All right, so let's talk about how we do this in Java. In Java, there's many ways you can do it. You can see here on the chapter objectives, we have if else, else if. We can nest our if-else statements. You can have an if inside of an if inside of an if. I wouldn't do that, but you can. And then you have the use of the and or. So like a very simple example would be if Mr. Rogers comes to class and he wears a button-down shirt, I will listen. Right? So what would make that statement true? They would both have to be true in order for you to do what's inside. But if I said something like this, if Mr. Rogers came to class and he wore a button-down shirt or he wore his glasses, then I will listen. What is the components that make that would fit the criteria? Right. Attendance and or shirt or glasses, right? Yes. You all would gaze at my beauty and go, no. I'm kidding. I would never do that. And or questions, though, are important. We inherently make these type of and or questions. We answer them all the time in our life. It's very important that you pay attention to what it means to have an and statement. Okay? If you have multiple criteria and they are all separated by ands, that means that everything has to be true, or you don't do the functional code that is embedded inside of it. That means if one of those is false, then you don't do the process. Now, a lot of beginning programmers, they make the mistake and they think that they have to put all of the criteria separated by ands, and when maybe it needs to be an or. When this or that, right? So make sure you pay attention to the or. The next one is the switch case statement. And this works off the idea that we have certain cases in life or scenarios that would match. Typically, cases would be things they're aligned to the data type. So if the data type coming in is a string, and I said, if the fruit, which is a string, fruit is the variable, and then the case statements below would be things like apple, orange, pear, mango, grape. it would fall automatically into one of those case statements and perform that piece of logic. Okay. There's some other things that we'll look at with the switch case statement, like a break and why you use a break inside of a switch case. And then we'll talk about the not operator. Does anyone know in Java what operator represents the not? It's just an exclamation point. Exclamation point will always equal the not. So if you have a variable that's of type Boolean and you put an exclamation point in front of it, you negate whatever that value is. So have you ever heard in English that you should never use double negatives? Because a double negative is it's the same way in Java. If you put an exclamation point in front of something and that value is false, then you're saying if it's not false, which means it's true, it will do the operation. Okay? So these are all important. And then access operator precedence. These are some of the mathematical decisions, like your pluses, your minuses, multiply, divide, things like that. And then we'll talk a little bit about constructors and so forth. Okay. So pseudocode. Back about 25 years ago, I took a class here at NMC. I had already had my degree, but they were offering a continuing education course on databases. And I wanted to learn. I wanted to learn about databases and database programming. And the guy who taught the class, he was pointing out the big issue that all software developers are going to be facing here in the near future was Y2K. Some of you are laughing because you're like, that's so last century, Mr. Rogers. It is so last century. But one of the things that he talked about, and I still practice to this day, is when I'm writing my code, I will sometimes go to a whiteboard and I'll draw out with non-specific coding language the processes that I want to do. This is called pseudocode. It's great to do it on a whiteboard. It's good just to get it up there and kind of map it out and draw some diagrams and give some ideas about the flow and the type of logic you want to do, because it helps you not to be tied down to your code too early. Pseudocode is very valuable. It's like a rough sketch, right? If you ever looked at some of these famous artists, before they even painted their first masterpiece of a person, they'll have a whole sketchbook filled with little sketches that detail what that masterpiece is going to look like. They've spent time sketching it out and producing it and getting an idea how they're going to do it. It's the same idea with pseudocode. Your flowcharts. So your flowcharts in Java are very important. And the first, which is very important for us in the flowchart world, is the diamond. The diamond represents the decision. Maybe you've seen some flowcharts like that. You'll have a line that comes in. Let me see, is there a marker over here? So you have, let's see if it works on the first go. Oh, look at that. Comes over and there is a diamond. And it's yes or no. This is the yes. This is the no. Right? And so this is represented by some question that will always resolve to a Boolean of true or false, right? So this is the starting point, and you get to this decision, and you have to figure out where your code flow is going to go from that point, okay? So your diamonds are always important for that. By the way, when you go on forward, you're going to learn things about loops, right? You'll also use the rectangle, which in this instance, the rectangle represents an unconditional step. Okay. All right. These are always good to have. If, especially as you get into, if pursuing coding later on and you get into a job, you'll see some diagrams that map out the code. And it's important to look at all of that, all of the requirements, all of the diagrams to get an idea of what needs to happen at each step. Okay, planning and decision. So you think about the sequence of the structure. One step follows the other in an unconditional fashion. By the way, I teach also over at Grace Christian elementary computer class. And I'm teaching coding to elementary kids right now. How cool is that, right? And so I talk to these kids about algorithms. And if you remember from day one, what is an algorithm? It's a sequence of steps, a sequence of instructions, right? And so I was playing with the kids and I said, tell Mr. Rogers to walk forward. And so they said, walk forward. So I start walking. And of course I run into the wall. And they're all laughing and giggling. And I'm like, well, you didn't tell me to stop. And so I get up there, then they say, stop. And I said, well, what is a way that we could handle it with these kids? What is a way we could handle the condition of meeting a wall? And they would say, well, if you meet a wall. And I'm like, yeah, there it is, the if statement. If you meet a particular condition, then you change how your algorithm is constructed, right? And you take these algorithms and a lot of times you'll embed them in something that you all learned about last week or the week before last. We call them not functions, but we call them methods, right? Embed your code into methods, making it more reusable and so forth. So think about when you create your methods, the return type. Is the return type of that method, should it be like a Boolean? Is it controlling some logic flow? Is it performing some mathematical calculation that you know you need to embed in there to determine if it meets a certain criteria? Think about how you use those. Okay. Any questions so far? You guys are with me, right? Okay. So here is a sample flow chart. It says, go west on the Algonquin Road. It's up in New Hampshire, I think. And then the next step is turn left on Roselle Road. Enter the expressway heading east, exit south on Arlington Heights Road. Proceed to 688 Arlington Heights Road. All right, that's a series of instructions, sequence of steps. If you think about how would we break a square, which is an unconditional step, how would we break that into something more reusable, like a decision flow? Well, in this instance, the unconditional step is go west on Algonquin Road, turn off on Roswell Road, and something about the expressway is messed up, okay? There's a decision. If it's messed up, then you're going to do these sets of tasks until you get back down to the original flow again. If it's not messed up, then you take the expressway and you do the shorter path. So you think about how to break your code into pieces of logic. This is ultimately, you have to begin to think like Tetris blocks. Like, how am I going to break these processes up into more manageable sequences? And I'm going to tell you something that once you start to do this, you'll begin to look at things in life and go, oh, I could write a function that describes that situation. I could put this logic in here that describes this particular piece. The only way you're going to do it is by practice. And so this week there are a lot of assignments because it's about you practicing developing, understanding the logic flow, the branching logic, okay? All right, any questions so far? Practice makes perfect, right? The more you do it, the better you're going to get at it. And this is a little bit different than most math problems. This is you taking real-world scenarios and writing code that describes it. So take the real-world scenario, maybe write some pseudocode first, get a handle on it, and then go, okay, I got my pseudocode, so now I'm going to take my pseudocode and I'm going to convert it now into Java code, right? Then, of course, your compiler takes it a step further and converts it into bytecode, so it can be understood by the machine code. Anyways.
Mr. Rogers.
Yes.
When designing like an algorithm to solve a problem, what would you recommend doing first? Like do pseudocode first or do the flowchart?
Pseudocode.
Pseudocode?
Write it out. And as you write your pseudocode, you're going to naturally draw pictures. I mean, there's something innate about us about drawing pictures and diagrams to map things. It's just natural to do that. And just do it. Just take the time to write out the problem in steps and then try to draw a picture that describes it, and then you can take that picture and refine it and make it into flowcharts and so forth. Yeah. So all things are yes or no, true or false, right? And when we look at if conditions here in a moment, the if condition itself has a parenthesis, and that parenthesis is where the Boolean statement is stored. Okay? That's where it's stored. A couple things about this. This Boolean statement can be comprised of something like a double equals. So you could have if A equals B, then you pursue your logic, right? A being a certain variable, equivalence, not equals. This is important. In JavaScript, you can get in a lot of trouble doing this because JavaScript will, if you tell it to use an equal, it's going to left assign the value. So if I do this in JavaScript, all I've done is I've left assigned B to A. Okay? So in Java, it is for determining true or false or comparing things, you use the double equals. Okay? Very important. Very important. Okay, other thing about this if statement, we're going to talk about it in a couple of slides here in a moment. This curly bracket is optional. Okay? Some of you are looking at me like, what? In Java, it's optional, but this is best practice. This performs readability so that it's very clear what the condition is or what the operation is you're going to run. Because there's scenarios, if you do this, A is equivalent to B, and then you write print apple, and then you hit a space, you go like a line down, also print cherries. What is the flow that's going to happen here? Think about it. A might not be equivalent to B, and so print cherries will always happen. And that might throw you off mentally. Why is it not working? Well, because you didn't encapsulate this in curly brackets, this is not dependent on this statement. Okay? All right. So you have to use the double equal sign to determine equivalency. Now the double equal sign is always going to return it's always going to implicitly return a Boolean value. Now there are some situations, like in how you compare strings, that you cannot use the double equivalency, but we'll worry about that later. All right, so let's look at this example. If quiz score is equivalent to 10, that's a double equal sign there, even though you may not be able to see it. Is everyone in the back paying attention? Okay. Remember, if you are watching videos and you come to me afterwards and ask for help, I'm probably going to tell you no. okay? Because this is very important that you pay attention right now. Thank you. If the quiz score is equivalent to 10, the operation it's going to perform is system out print line, the score is perfect. Now, in this example, you can see that there's not curly brackets, right? It's because the system out print line is right underneath it. If you move that system out print line an extra line below, that statement now would no longer be dependent upon the if condition, okay? So again, best practice, always use curly brackets to wrap in your logic. All right, any question here? Okay. So then you also have something called an if-else. So if-else is exactly what you would think it is. If-else is where you say, if this is Boolean, else, right? You have the instructions that are run. The instructions that are run. So think real quick. Let's say if test score is equal to 10, perfect score. Else, not a perfect score, right? This is a very precise statement. Got an ant on me. This is a very precise statement. This is the catch-all, right? Okay? And you can take it even a step further. You could say, if this, else, if, right? And you could add another Boolean for it to evaluate. Maybe this scenario is if the quiz score is a 9, system out print line B. If it is a 10, A, right? You could think of different scenarios. And then if you have this, you could also have another else down here. Okay? Same rules apply. You're not required to have the curly brackets as long as everything is one line under the other. As soon as you introduce spaces, this code will probably not compile or it'll produce strange results. Okay? All right. Let's do a couple of examples. All right. This is the relational operator, and we'll run an example with that condition. Let's do open up IntelliJ. And I'm going to do a, you know what? I'm just going to do a new class inside of this one. If you have, just open up a new project. Okay, I'm just going to open up a new class here. This is going to be branching logic, and I'm going to go ahead and use a system out. What is this thing? Public static void main method. And I'm going to put a scanner in. Call it input equals new scanner system.in. Please enter your favorite fruit. Okay. So let's let's encapsulate this in a method. Public static Boolean is good fruit. String fruit. This is totally subjective, okay? So I've got a public static void main method that's determining a condition. And here I'm going to say input dot next line. And for purposes of just keeping the variable available, yeah, we'll just call it fruit. Okay? And what I'm going to do is I'm going to say is good fruit, pass in fruit, and this is going to return a value, so I'm going to assign it. Okay? Everyone follow me so far? All right. We're going to do another one in here as well. We're going to create another method because I want to show you, I want to give you the demonstration here of how you compare between primitives and objects. It's very important. Primitives and objects, the way you do comparison, you have to be careful. Okay? So is same price. We'll do double price. Okay? So here, I'm going to, let's do this. Let's add a couple of constants up here. I'm going to say private final static apple equals apple. Private final static, oh I forgot, string, right? Let's do another one. What's another fruit you guys? Mango. Mango. Private, final, static, string, what's another fruit? Tomatoes?
Yes. Tomatoes are fruits. Don't argue with that.
Tomato. There's a guy on YouTube. His name is Integiza. Anyways, his catchphrase at the end is, and don't forget, tomatoes are disgusting.
Oh my god. They are. A little bit. No, actually not. They're not.
Yeah.
Sorry.
Did I misspell it? Tomato.
No E.
There you go. All right. So we got three fruit, okay? And these are constants. We know they're constants because number one, they're final and static, and for constant variables, you always make the variable name uppercase, right? So let's start with is same price. So I'm going to come in here, I'm going to add another variable to this. I'm going to say the fruit. So that's going to take a fruit and a price. And I'm going to say if fruit, this is where it gets interesting. When you go to compare strings, you have to use a special method. And this has to deal with the way strings are stored in memory. every string is stored in a master cache, and they do this for performance reasons. But because of that, all references to the strings are pointers. And when you go to do comparison of value for a string, you can use the equivalency operator, but that does not necessarily mean that what you're comparing is going to be the same. When you use something like that for comparing strings, you're saying I'm comparing the location to this value, and it's never going to equal. So therefore, this statement, apple is equivalent to my constant, is not going to return true. Because one is, this is pointing at the location in memory. And the location of these two things in memory are different. So the way you deal with objects then is you have to use either the compare to operator, which is that, compare to ignore case or compare to, or for strings you use the equals or equals ignore case. Equals is going to compare and just trust that the value is the same case. Right? Equals ignore case, as you know, does what? Doesn't care if one is caps and the other is lowercase. It just compares the two. So when I want to compare strings, I cannot do that. This is wrong. Okay? Don't do that to try to compare if the values are the same. Because it'll run, but it won't give you the same value. It'll always return false. Okay? This will compare the fruit passed in with the constant. And so I could type in uppercase when I use the method apple, right? And because I have equals ignore case, it's going to say, yep, they're the same. All right? So if fruit equals ignore case, right? And if the fruit is that, then let's set some other constants up here. We'll say final private, final static int apple, whoops, double apple price. How much do you think an apple will sell for? $3.50. Okay. Let's do another one. What's the other one we got up here? Mango? What do you want the mango price to be? 50 cents. Okay, what about tomato price? What's the price of a tomato? Okay, I don't care. $1.99. We got to get going with this. We're taking too long. Okay, so if the fruit ignore case equals that, and you're going to be looking at me going, that's not the word and, Mr. Rogers. In Java, it is. Okay, if the fruit equals ignore case, apple and price is the same as apple price, then return true. Else, return false. Now, for our purposes, tell me what's going to happen here. Okay, Elijah?
So basically, you're setting up the price, and if it looks like a different price, it'll ignore it.
Yeah. Yeah. So it could be an apple, but if my price is wrong, then, right, it'll say it's false. Or it could be not an apple, but the price could be right, but it's still false, right? So that's important. Now, if you're just comparing things like, is this a good fruit? If apple equals ignore case, fruit, return true, right? And so when we look at this, let's go ahead and do another final Boolean is same price equals is same price fruit and price. And price doesn't exist yet, right? So we're going to do this. Final Boolean price input next double, and we'll just put a system out print line there. I'm going to take out the line because I don't like that. I want my input to be on the same line as the question. Okay. Please enter the price for your favorite fruit. Okay? So, what's wrong here? Oh, there we go. So we have that. Now, maybe I want to have another method. Public void display results. And this could be a Boolean for good fruit and a Boolean for same price. And I could say if good fruit, system out print line, you chose a good fruit. I keep misspelling fruit, right? Else, system out print line, you chose a terrible fruit. If same price, you chose the same price. All right. That's my display. So then I come down here and I'll pipe in that, public static void. So display results. I got to pass in my good fruit and I got to pass in the same price. Now, what I've done, right? All I've done is externalize my logic into methods that handle the types of branching conditions I want to do, right? And this may not be the best way to do it, There may be other ways you could write your code and organize it, but for purposes of demonstrating, we're doing number one, we're separating our code into reusable chunks. We're making sure we're handling appropriate objects versus equivalency of numbers, right? I'm demonstrating here, somewhere in here. Where is it at? Where's my ampersand? Oh, here it is. Showing how to use the ampersand. By the way, you could also change this out, and you could say or. So now if I make it or, only either one of these conditions has to be true for this to return true, just because there's an or. Okay? So you have the double ampersands or the double pipes. Okay? If you're looking for the pipe symbol on your keyboard, it's usually right underneath the backspace. It's right there by the backslash or forward slash, whichever one you call it. Okay? All right, so let's run our code. Oh, we got a condition here we didn't meet. If the apple, is it a good fruit? Else, return false, right? Now, we're excluding all mangoes and tomatoes. We're not even verifying the logic, but we know what we got to do to add that logic, right? We just say else if the next fruit, right? Okay? All right, so let's go ahead and run it and see what we get. There we go. Solve that problem for right now. Now we'll run it again. Okay. Please enter your favorite fruit. Mango. Please enter your price. $3.55. You chose a terrible fruit, right? But that's the idea. We're learning how to pass our logic off. Okay. Any questions so far? Any questions? All right, let's go back to our slides real quick. So remember, this is a pitfall if you try to compare objects using a relational operator. The relational operators are the double equals. You can also use a relational operator in terms of a exclamation equal. So I can also write this same statement like this. This marker's dying on me. You can write it like this. Okay? So now I'm saying if A is not equal to B. A not equal to B. That's what that means. All right? Okay. So you have if-else statements used for dual alternative selection. You can use an if with an else, or you don't necessarily have to have it, or you can have an if-else if condition, right? The statements inside, these are the statements inside. whatever these statements are, they have to end with a semicolon. Okay? Whatever that statement is. Right? Just like a regular line of code. Computer sees it and says, okay, that's end of the code block, go to the next line and do the next statement. Okay? All right. Real quick question. If a statement is sometimes, an if statement is sometimes called what? It's sometimes called a conditional, right? Conditional alternatives selection. Right? Oh, single alternative selection. Okay. Yeah. If statement is sometimes called a single alternative selection. There we go. All right. Multiple statements. All right. We've already kind of talked about multiple statements here. You can nest your if statements. So in my code sample, we could have, something like you could have another if statement in here. If, I don't know what it would be because I only have one parameter, but you can certainly include other if conditions inside your block. Okay. This might be a better example. If good fruit, same price. If good fruit, if same price, right? You could do that. And then we could do this. Let's say you chose a good fruit and the same price. System out print line. You chose a good fruit, but you don't know how to shop. Okay? So there's an example of us applying that same type of if conditions inside of nesting it. And down here you could say, I don't know. You could do different things. All right, let's go back to our slides. Else statements are always associated with if on a first in, last out basis, right? So go into the if statement, and then finally the last if none of the other conditions are met. So you could have, we could go ahead and do something up here. Where's is good fruit? Let's say else if mango dot equals ignore case fruit return true, else if what are the other ones we have? Is it mango, apple, and tomato? Okay, so let's just say return false, right? It's implicit because they only have three fruits up there, apple, mango, and tomato. I could be explicit about it, but this idea here is by condition. I do this first. If this doesn't meet the criteria, then I go down to the next line. If that doesn't meet the criteria, then the else will catch all. Okay? However, if you fall into one of these criteria, you'll never go to the else. Okay? So you can't, if you want, if you wanted to, you could override it and say return true. But that doesn't really make sense because I'll never get there. It's an unreachable statement in this code. I could do this. That's implicitly the same statement as else. Right? You see, understand the logic? Okay. All right. Any questions? All right, so you have your logical and your logical or. We talked about those. This is your and operator. Your logical or is the double pipe statement. If you accidentally compare, only use a single ampersand or a single pipe, you're still doing comparison, but it's called bitwise comparison, okay? And it's not gonna produce the same results that you think. You're actually comparing bits, and yeah, okay. All right, so short-circuiting your code. Let's talk about this. The idea of short-circuiting your code here. Where are you at? Here we go. If I want to short-circuit my code and make the code run quicker, I may want to put the false condition first. So a good example of this might be something like, let's run an if statement here. If my condition I want to test for could be that I want the tomato to fail first. Okay? Because tomatoes are disgusting. I'm kidding. I'm just picking on tomatoes right now. But if I want to have the tomato fail first, if I'm checking for the tomato, I don't want to put it at the end. I want to put it at the front of the condition. Okay? So if tomato equals compared to fruit and, right, my list of comparisons. The idea is you want the item that could fail in a double ampersand situation, you want it always first. So if it has to fail, it fails on the first try instead of going all the way to the last condition and finding out, oh, you can't do the condition now. You short-circuit it by forcing it up front. Does that make sense? Okay. All right. Okay, we've already talked about pseudocodes and flowcharts and decision structures. Let's see, efficient decisions. A series of if statements that determine whether a value falls within a specified range. Typically, we would do those like this. So I'm going to create another class here, and I'm going to call it comparing numbers. Public static void main method. And I'm going to have int, let's see, low equals 0, int mid equals 5, int high equals 10. Take a scanner, input, oops, scanner, input, new scanner, system.in. Please enter a number. Okay? Let's change this. Let's make this int magic number equals math random times 10. What is I'm trying to remember how to do this. Let's just, for our purposes, just do this for right now. Okay. So my number equals double my number equals input next double. System out print line. You entered my number. All right, let's just run it just so we can see the code for a moment. Okay, so we have 2, you entered 2. All right. When we're comparing ranges, we could do something like this. If my number is greater than or equal to magic number, let's just do greater than. If my number is greater than magic number, system out print line to high. Else, if my number is less than magic number, to low. Else, system out. Perfect guess. Okay, so let's run it. Magic number 4. Okay, you entered 4. Wow. Either I was lucky or yeah. Let's see. Let's output the magic number for. See if my code is wrong. Okay.
You're just really lucky.
Math.random. What is the?
You should just output like a double.
It's times 10, right? Yes.
Why did you say my number is less than 900?
Oh, thank you.
Oh, yeah.
Thank you for catching that. But also, I'm trying to. I think this is off because I'm never going to be.
This way you still want to disengage.
Yeah. What is it? Off the top of my head, I can't remember. Java round random number.
You can do it from disengage. It's int. And then
There we go. Let's try it again. All right, so we'll do 4. Okay, so that time is too high. Do it again. Will equal 5. Too low. Do it again. 7. Too high. All right. So when we're talking about ranges, though, in this instance, when I'm thinking about the ampersand and the or, there's a way that we could possibly to deal with this a little bit more precise, right? So if my magic number is greater than, if my number is that, let's say that when you're dealing with ranges, this isn't going to work with a random number, I don't think. Let's see, if my number is less than that, and greater than, let's see, number is less than that, and my number is greater than 0, system out print line too high, system out print line I have a range of 0 to my number, right? Now, in this instance, I'm creating a range. If my is greater than, and less than 10. If my number is greater than the magic number and my number is less than 10. So here we're catching a range, right? And we could also do this as that. We could, trying to think of the best way to term this. The magic number is in the upper range, right? My number is greater. Yeah, you know what I'm trying to go after here. But you can develop ranges for your number system. Okay. All right, kick me out. Let's go back in here real quick. We got about 10 minutes left here. Any other questions that we haven't addressed so far? Any other questions? We haven't done the switch case statements, right? So let's, and here's the switch case. Let's go ahead and create a new Java class. And we'll call this a switch case example. PSVN, public static void main method. I'm going to get this up here for you guys. I'm going to give you just a basic example from the W3 schools. So let's see here. What we're going to do is I'm going to have an int called day. We're going to set that like that. Then we're going to do a scanner. Input equals new scanner system.in. Please pick a day. So let's think about the situation where we want to pass in a number and return the day of the week, right? So the switch case statement would begin with something like this. You would say switch, and just like an if statement, you have a parenthesis, and you're going to specify the variable that you're going to evaluate, okay? You have your curly brackets that you're going to use. And for this particular scenario, I still have to populate my day, so I'm going to say day equals input dot next int. Please input a number for the day of the week. Okay? So typically what I would do is you'd have the case and then you would specify the scenario. What follows the case must be the value that matches what's in the switch. And what type is in this switch statement here? It's an int. So I'm going to say 1 semicolon, system out print line, Monday. Then what I have to do is I have to break out of the case. Okay? And I'll come down for my next case statement. Case 2, system out print line, Tuesday, break, case 3, system out print line, Wednesday, break, right? And I would specify all of the cases all the way up to 7, right? Now I can also do something different. I can provide a default. The default essentially acts just like the else. It's the final scenario, meaning it's the catch-all. Whatever is not caught by cases 1, 2, and 3 is going to fit into that final scenario. So system out print line could be Thursday through Sunday. Okay? Very basic code. If I run this, let's come back up here and run the code real quick. Enter a day of a week. I'm going to say 3. Hit enter. It's Wednesday. Under this case statement, because if I enter any number that's not fitting the scenario, if I enter, say, like a 6, could be Thursday through Saturday, Thursday through Sunday. Now here's the other interesting thing. If I take out a break statement, what it does is it'll do this item and then it'll fall on through and see if it fits any other cases. So think about what's going to happen here with the break statement commented out. What other statement will it hit? It'll hit the default. If it hits 1, then it's going to check and see if day is also, if the case matches here. If it doesn't match there, it doesn't match there, then it's going to go to the default. So in this scenario, because I commented out the break, watch what happens. As long as I enter a 1, right? Because that's the scenario where this situation will occur. I enter 1, and I go Monday, Tuesday. Interesting. Right? it fell into the next case statement. It didn't do what I thought it would do. All right. The break statement, though, is important. You could have it where the logic could match multiple cases. Okay, this would be I had a scenario where on some code we worked on down in Key West, where a value that came in, if it was a certain entity type, and the entity was represented by numbers, and these entities could be vehicle, what they called targets that we were tracking. It could be a person, they could be a vehicle, they could be a boat, right? And if it matched any of those entity types, it would fall into those cases and it would do a particular thing. In our scenario, we had a map, which is a type of collection that we would add that entity to for use later. All right, so this is your switch case statement. Your switch case could be a string, right? It could be an object. Under the new JDKs, you can set this up to also be objects, specialized objects that represent your values. Okay? So it could be a custom object that you've created. All right. So here's the example they give, right? All right. We've covered all of those. Operator precedence, so you can combine and ors together, right? But just remember the precedence of what happens as you combine them. Put them in parentheses. Like you could have an and statement wrapped in a parenthesis, or another and statement, or you could have an or statement separated by an and with another parenthesis of an or statement. Okay. Order of operation precedence from highest to lowest. So you got logical not, multiplication, division, modulus, addition, subtraction, relation, equality, logical and, logical or, conditions, and assignments. Right? And what is an assignment? It's just a single equal sign. Single equal sign. Equivalency is 2, right? Okay. All right. Making constructors more efficient using decisions and other methods. Yeah. All right. We're done. As always, if you have issues, I'm going to be over in the other lab for a few minutes, and we can chat there. This week, just to look at your assignments again, let me just this one is a good example where you have to create a method that does that type of logic, right? It's determining, is it even? And what is if you pass in a number, what is an easy way to determine if that number is even? Yeah, but there is a particular operator, modulus, because if you use, like, say 5 modulus 2, it's going to give you the remainder. But if it's 4 modulus 2, it'll always be 0. And you'll always be able to determine if a number is even by using that number modulus 2. Right? Otherwise, it's not even. It's not an even number. Okay? All right. Let's take a look at the next assignment. The one after that is your ascending and descending. So you're going to write an application that asks a user to enter 3 integers, and you're going to display them in ascending and descending order. Yeah. You have to sort them. So this is where you're going to use those if-else statements, how you're going to take them and put them in the right order. Okay? All right. The next assignment is called the shady restroom. So this one is one that's going to involve 2 classes, which means that you'll have to turn in 4 files. A screenshot for the shady restroom and a script. Don't take this the wrong way. I don't want a picture of your toilet, okay? Some of you are thinking, "Oh, this would be funny. I'm going to send him a picture of my toilet." Yeah, don't do that. All right. Let's see. Assignment 4, cell phone service application. Okay. For Horizon phones. Horizon. No. Yeah. Okay. Assignment 5 is the Acme Pay. No, we would be shaking if it was an earthquake. Y'all were there last year when that happened, right? The whole room was shaking for a little bit. Maybe it was spring semester last year, because this would happen all the time. The thing will jiggle, and I'll wait for whoever's upstairs to stop moving desks around and everything. And then one day there was a boom. That was jiggling, but I also noticed that my desk was jiggling. I thought, man, they're really loud up there. But it was like a 5-point-something earthquake that hit. Assignment 12, 12 Days of Christmas. So in this assignment, you got to go out and get the lyrics, and then the person's going to enter the number for the day, and then you're going to display. Make sense? Okay? Yeah. And then you got your quiz, review quiz at the end. I want to remind some of you, I've been looking at the assignments, and a lot, either you've not been turning in your assignments or you just like forgotten. I don't know. There is no alternative to that condition I just gave. Because Cengage for those assignments is not broken. Please don't get behind. Here in a couple weeks, I have to lock down and close off assignments. Okay? So in 2 weeks, I'm going to start locking them down. And if you haven't finished those up in the past, you're going to start failing. Okay? Because this is a hard class. All right? So please get everything caught up. All right. I'll chat with you later, guys. Ladies and gentlemen.